Hi there, Mr. Sutton here, bringing you the Algebra 2 7-5 Part 1 homework solutions on solving rational equations. This one we're focusing on solving by cross-multiplying and finding inverses. For this question, I have two fractions with an equals between them. This is a good cross-multiplying situation. So let me do 4 times this x plus 6 on one side, and then we'll have the 2x times the 5 on the other side. So distributing and cleaning this up a bit, we have 4x plus 24 on the left. On the right side, that's going to be 10x. And then I can subtract 4x to the other side. That'll give me a 6x over there. Dividing by 6, we see that x equals 4. Or does it? Let's double check. If I plug 4 back in, I'm not going to get 0 in any denominators. So this one is good. For this problem, I have kind of an a over b equals c over d situation, so let's use cross multiplying here. So I've got x plus 2 times 9 on one of those sides and 3x times 4 on the other. Distributing, we've got 9x plus 18 equals, this will be a 12x over here. Let's move that 9x over there, so subtracting we get 3x. And then dividing by 3, we're going to have x equals 6. Now just double checking, if I plug 6 in for x, I don't get 0 in either of these denominators, so we're good to go on this answer. For this one, I have one term on each side, so I can use cross multiplying to get those x's out of the denominator. So on one side, I'm going to have negative 2 times x plus 1. On the other side, I've got the x minus 1 times the x minus 8. And now let's distribute on each side and simplify a bit. So we've got negative 2x minus 2 on the left side. On the right side, we're going to have x squared minus 8x minus 1x plus 8. This is a quadratic, so let me just move everything over to one side and zero this out. We'll keep the x squared over on the right side there on one side. Also on this side, we have negative 8x minus x, that's negative 9x. If I add the 2x over there, that's now going to be negative 7x. And then if I add this 2 to combine with the 8, that gives me a plus 10 over there. Well, I think I can factor this. Things that multiply to 10 and add up to negative 7. 1 and 10 doesn't work. 2 and 5 does if they're both negative. So we have x minus 2 and x minus 5. Setting each of these equal to 0 and solving, we've got x equals 2 and x equals 5. And then just double checking, if I plug these back in, I'm not going to get 0 in either of my denominators, so these are both good. For this problem, we're trying to figure out the inverse if there is one. So I don't see any even exponents, so we're good to go on this one. Let's just switch x and y. So I'm going to write x equals 2 over y minus 4. And then I'm going to switch the x with the y minus 4, so we have y minus 4 equals 2 over x. And then we're just going to add 4 to get f inverse equals 2 over x plus 4. For this problem, finding the inverse, let's double check and make sure there's nothing that would disqualify us from getting an inverse. So I don't see any even powers or absolute values or anything like that. So let's go ahead and do the process then. We're going to switch x and y. So I'll write x equals 4 over 11 minus 2y. And then to get the y out of the denominator, let's multiply it up here and then divide by the x. So I've got 11 minus 2y equals 4 over x. Basically just switched these two. Next up, let's subtract 11 from both sides. And then finally, to get y by itself, I'm going to divide everything by negative 2. So we're going to have, let's see, 4 divided by negative 2 is negative 2. So that's going to be negative 2 over x. And then negative 11 divided by negative 2, I'm just going to call that negative 11 or positive 11 halves. For this problem, they want us to find the inverse if there is one, but I always want to double check in the beginning to make sure there's nothing that would prevent me from having one. In this case, that pays off because this x squared here is going to prevent us from having an inverse. If I plug negatives and positives in here, it does the same thing, the same result for both of them. So I would not be able to figure out whether I originally plugged in a negative or a positive if I were to go the other direction. So this x squared means we have no inverse and this problem is just done. Can't be done. For this problem on the honors set, we're talking about making some brass. Brass is an alloy with 55% copper and 45% zinc. And let's say we have 25 ounces of copper. We want to know how many ounces of zinc we need to make brass. So essentially we're trying to get this 55% copper ratio. So kind of a general formula we could set up is that our percentage of copper equals the amount of copper divided by the total weight. So this is what we're going to have to plug a few things into in order to get some brass. Now if I want brass, this percent copper needs to be 0.55. And this is one way to do the problem in terms of the amount of copper. You could do it in terms of zinc, but I think the copper works out a little bit easier. So we've got 0.55 for that. And the amount of copper, they said that we are starting with 25 ounces of it. So that's just 25. The total weight is going to be the 25 ounces of copper plus however much zinc you're going to add. Now that's what we're controlling here is the zinc that we're adding, so that's going to be our x. So 25 plus x will be our denominator. And at this point we just have an equation that we can use a little cross-multiplying sort of reasoning on to get to the answer. So to get this x out of the denominator, let me just multiply both sides by 25 plus x, and I'll use the calculator for that. So really I just need to do 25 times 0.55 on the calculator, and that's 13.75. So we have 13.75 plus 0.55x equals 25. Subtracting 13.75 from both sides, we've got 25 minus 13.75, which is 11.25. And then if I divide both sides by 0.55, let me just do that. 11.25 divided by 0.55 comes out to about 20.45, if I round that off, 20.5 ounces of zinc that I have to add to get brass.